Good afternoon. Thank you very much for watching. In today's video, I would like to continue discussing the block diagram. In my last video, I covered the flash program memory, program counter, 8-level stack, the RAM, port A and C. So now I'm working downward, and some of these things aren't as fundamental to the chip. Well, everything's fundamental, but I don't know, how do I define direct addressing, the program bus? I mean, they're just not core components, but I'm still going to work through this. Okay, enough intro. But in explaining some of this, it brings up some programming concepts. So I'm going to begin this video here with defining some of what I think is necessary. Okay, so I'd like to talk about what an immediate address or an immediate value is. So in PIC programming, an immediate value is a constant value specified directly within an instruction. Instead of referencing a memory location or a register to fetch the value, the immediate value is embedded in the instruction itself. For example, consider the following PIC assembly instruction: move LW 0x1A. Here, 0x1A is an immediate value. The move LW, move literal to the working register, instruction tells the microcontroller to load the literal value 0x1A directly into the W register. Immediate values are used to perform operations with known constants quickly and efficiently, as they do not require additional memory fetch cycles. What I gather is that an immediate value is a constant value. It's just stated. You don't have to go looking for it in a RAM memory location. It's a constant. And therefore, you don't have to go fetch through instruction cycles to go get the value. It's just stated as a constant. Alright, so the next definition I would like to cover is direct addressing. So in programming and in PIC programming, direct addressing is a mode where the instruction specifies the exact memory address of the operand. The address is given explicitly in the instruction, allowing the CPU to directly access the memory location without any additional calculation or lookup. For example, in PIC assembly language, consider the following instruction: move F 0x20W. Here, 0x20 is a direct address. The move F, move file register instruction, tells the microcontroller to move contents of the file register at address 0x20 into the W register. In direct addressing, the operand is located at the specified address. It provides a straightforward and efficient way to access data stored in specific memory locations. Direct addressing is commonly used for accessing specific registers, I/O ports, or memory locations within a microcontroller or other computing system. So just to emphasize, the address, which in this case is 0x20, is explicitly in the instruction, which allows the CPU to directly access the memory location without any additional calculation or lookup. So, yeah, you don't have to do any calculation or any extra effort on the part of the CPU. The operand is in the memory location. That is direct addressing. Hi nerds! I expect you enjoyed watching my last video. You're welcome. I'll reward you with another video. Today I am further discussing the block diagram of the PIC16F684. It's really important that you subscribe, so go ahead and do that now, please. Alright, so let's take a look at the PIC16F684 block diagram. In the PIC16F684 microcontroller, the program bus is an internal pathway used to transfer program instructions and data between different components within the microcontroller. Specifically, it connects the program memory, where the program instructions are stored, to the CPU. Here's a breakdown of its role, and we are talking about the program bus, which might seem simple, but there is a fairly lengthy explanation. So here's a breakdown of its role. Fetching instructions. The program bus is used by the CPU to fetch instructions from the program memory. These instructions are stored in the program memory as a sequence of binary codes. Instruction execution. Once an instruction is fetched, the CPU decodes and executes it. The process may involve reading or writing data to or from other parts of the microcontroller, such as the data memory or I/O ports. Once again, we're talking about the program bus, and this is a breakdown of its role. So we talked about fetching and instruction execution. Now we're going to talk about addressing as related to the program bus. The program counter, PC, in the CPU holds the address of the next instruction to be fetched from the program memory. This address is sent over the program bus to access the correct memory location. Transfer of data. In addition to fetching instructions, the program bus may also be involved in transferring data that is part of the program instructions, such as immediate values or addresses for branching operations. So there's that term that I defined at the beginning of this video, immediate values. So I'm talking about the program bus, and one of its roles is the transfer of data. So I'll just say it again. In addition to fetching instructions, the program bus may also be involved in transferring data that is part of the program instructions, such as immediate values or addresses for branching operations. In sum, in the block diagram of the PIC16F684, the program bus is typically depicted as a set of lines connecting the program memory to the CPU, indicating the flow of instruction codes from the memory to the CPU for execution. This bus is crucial for the operation of the microcontroller, as it ensures the proper sequence and execution of the stored program. Alright, let's talk about what the instruction reg is. You can see the instruction reg shown in the block diagram here. The instruction reg, or rather instruction register, shown in the block diagram, is a critical component in the microcontroller's CPU. Its primary function is to temporarily hold the current instruction fetched from the program memory before it is decoded and executed by the CPU. So here's a detailed explanation of its role, the role of the instruction register. And there's 4 different roles. It is involved in fetching, decoding, fetching, holding, decoding, and executing. So first, in fetching, the instruction register, which is what we're talking about. So in fetching, the instruction register receives the instruction from the program memory via the program bus. This instruction is fetched based on the address specified by the program counter, PC. The next role is holding. Once the instruction is fetched, it is stored in the instruction register. This temporary holding allows the CPU to decode and execute the instruction while the next instruction is being fetched from the program memory. The next role of the instruction register is decoding. The instruction register contents are decoded by the instruction decoder, which interprets the binary code of the instruction to determine the required operation. Next, the role of the instruction register, it's involved in executing. After decoding, the CPU executes the instruction. This may involve various operations such as arithmetic, calculation, data transfer, logic operations, or control operations. But that's not really what the instruction register is doing, but I guess it's the next step. In summary, the instruction register in the PIC16F684 block diagram is essential for holding and processing each instruction fetched from the program memory, enabling the CPU to perform its tasks sequentially and efficiently. Basically, the instruction register is a thing. It holds the instruction for processing. Next, as you were looking at the PIC16F684 block diagram, you may have asked yourself, what is the ADRMUX? I'm glad you asked, because I have an answer. In the PIC16F684 microcontroller, the address mux refers to the address multiplexer. This component plays a crucial role in managing the addresses sent to the program memory and other memory components within the microcontroller. Here's a detailed explanation of the address multiplexer. Address selection. The address multiplexer selects between different sources of addresses that need to be sent to the program memory or other memory components. These sources typically include the program counter, which provides the address of the next instruction to be fetched, and potentially other address sources for specific operations like interrupts or jumps. Program counter. The address multiplexer, MUX, typically selects the address from the program counter during the normal execution flow, allowing the sequential fetching of instructions from the program memory. Interrupts and jumps. When an interrupt occurs or a jump instruction is executed, the address multiplexer switches to select the new address provided by the interrupt vector or jump instruction, redirecting the execution flow to the appropriate memory location. Efficiency and control. By using an address multiplexer, the microcontroller efficiently manages the flow of instruction addresses, ensuring that the correct instruction is fetched at the right time. This is crucial for the microcontroller's operation, particularly in handling sequential execution, branching, and interrupts. In summary, the address mux in the PIC16F684 block diagram is an address multiplexer that selects the appropriate address source, usually between the program counter and other sources, to access the correct memory location, enabling proper instruction, fetching, and execution. Alright, I am going to end this video here for now. I want to continue to examine the PIC16F684 block diagram. However, to fully explain my next topic, it requires an explanation of indirect addressing. So I'll cover that in my next video. Thanks for watching, stay tuned, and please subscribe. I will mention, I am not an expert. I'm really not. Chances are, if I'm covering this material, it's because I'm learning it. Thanks for watching.